Okay, so we said that our number of reactions is our total number of reaction over here is, let me say, let's count 1, 2, 3, 4, 5. Okay, so we have,
Akbane, ala ka kung bring
so in this case, our total number of reaction is equal to 1, 2, 3, 4, 5. So our total number of reaction is equal to 5. Okay, so even can someone go ahead to classify the structure for me straightforward even before we go to solve? Since our total number of reaction is 5, okay, and our what? Our EC is equal to what? Our EC is equal to 3. Okay, our EC is equal to 3. Okay, so from here we can go on to solve our problem. Okay,
Yes. Okay.
please let's all mute our mics, please, in a very big place, because I'm recording. Okay, so if you are making noise, it will disturb the lectures, and at the end of the day, if you are playing it later to learn, you find challenges. Okay, so let's come to the solving of the problem. So we said, first of all, you are going to come, what are you going to do? You are going to do what? Giving.
Draw the free body diagram.
So no, first of all, you come to your what? You come to giving. Okay, so this is your giving. So in the giving, what do you do? And let's say the giving is actually your question paper, the one you are going to be answering the question on in the exam hall. Okay, so you draw the problem for 1 mark. Okay, if you don't draw the question again, you will lose mark. Please, in a very big place, let's all try and remember to draw the question again even before we start to solve the problem. Okay, so let's assume what I've drawn over here, this is just a freehand sketch. Okay, so forgive me for my drawing. Okay, and it has, let me say, 3 internal hinges. It has 3 internal hinges. They'll always label the part for you. Okay, so please, in a very big way, you should always try to consider them in your calculation. This is a continuous beam. Okay, and he said that this was our H. And this also is a hinge. And this also is another hinge. Okay, so let's say this is the question paper we are writing on now. Okay. So after this, what do? You label the part. Okay, if you don't label the part, no one knows what you have drawn. Okay, so you have to tell us that it's original structure. Okay, so over here you can write original structure. Please, how was the exams?
Hard.
It was difficult. You remember I told you guys that don't rely on any formula. You should learn the formulas on your own. You realize whatever I told you, you went to meet it. When you went,
But it wasn't easy. You see, we were learning other courses, so it was disturbing.
oh yeah, you are very. You see, we are in the university and we can't do anything about it. We came to meet it and we just have to. When you go to the room, you do what the rooms do. Okay, so you only just have to adapt. And intelligence is the ability of being able to adapt to changes. We say that if the drum beat changes, you have to also what? Adapt or change the dance to suit the drum beat. Okay, but small, don't worry, life will be much more easier. So after drawing the structure and you write original problem, then you can come to your solution. Okay, so this is our solution. Okay, and this is actually the A part of the question I'm solving, of the trial questions. There are possible examination questions. So from here, what do? We are coming to draw the free body diagram. We are going to draw the free body diagram. we're going to draw a free body diagram. Okay. So because this is a hinge support, how many reactions am I going to put over here? I'm going to put 2 reactions over here. Okay. Good. And I'll indicate my ECs in the question. The EC is just a circle. Okay. You just draw a circle to introduce or to represent that this is your hinge. This is your hinge. And this is also your last hinge. Please don't get confused. They are all EC. Okay, they are all equations of conditions. Okay, so this is your roller support over here. This is also another roller support. And this is the last hot roller support being placed over here. Okay, please do well to you let's forget about the wraps. Okay, which direction is this one moving in? They are all reactions. Okay, they are all reactions. So let's label their part. They are all reactions. They are all reactions. They are all reactions. Okay. They are all reactions. Okay. So let's come to the technical aspect. Please, which direction is this one moving in? This one is moving in the y-axis. Okay. You can see that this one is also moving in the what? Y-axis. This one is also moving in the y-axis. This is also moving in the what? Y-axis. It's only the last one. Okay. That is moving in the horizontal axis, is moving towards the what? X-axis. Okay. So that's why this is going to become the Rx. That's reaction X. Good. After doing so, we are going to write here free body diagram. Free body diagram. Okay. For another mark. If you're able to do even just this alone, you will get marks. Okay. To have a loaf of bread is better than none. But I'll urge you to try and really understand the concept. Okay. Not also for examination purpose alone per se, but to help you towards your entire life. Okay, because your juniors are going to be coming soon, and most of them are going to be coming to you with questions for you to help them with. And if they come and you are not able to help them, you realize that you are going to be so much uncomfortable. Okay. Next semester, I'm going to be directing most of them to you. In case I teach them something and I realize they are still encountering problems, I'm going to be directing them to come and see you people to take them through. And that is what I'm going to be doing. Okay. So if they come and you are not able to take them through, you realize that it becomes a burden on yourself. Okay. So please try and understand the concepts so that even when you find yourself in level 400, you could even still explain this to someone without even watching anywhere. So we are coming to our classification. And in the classification, because all or much of the work has already been done, what are we going to do? What do we do over here? We say the total number of our reaction over here is 5. Okay. Okay. We could even also count it straight away from here. This 1, 2, 3, 4, 5. Okay. So we write number of reactions. Number of reactions. Our number of reactions. And the number of reactions is equal to, or let me say the number of reaction, comma, okay, the number of reaction, comma, is equal to 5. Okay, the number of reaction, comma, which is what? R, is equal to 5. Then from there, where are we going to? We are going to our equation of condition. So this is our equation of condition. This is our equation of condition. And how many equation of condition did we discover?
3.
Thank you. So the equation of condition, comma what? EC is equal to 3. Okay. So what other next thing do? We have to analyze the structure and know that because we have encountered a problem in the question, because EC has been seen in the question, it means that we have to apply the knowledge or the idea from the second table. Okay, that is because we realize equation of condition is the point. We have to add the equation of condition to what? Our constant, which is the 3. Okay, and the number we are going to get, we compare that with our number of reaction, and that will determine whether the structure is going to become unstable, determinate, or indeterminate. So from here, we are going to move to the constant, and that is what? 3 plus what? 3 plus EC. 3 plus EC. So in this case, what are we realizing over here? Realize that we already know the value for our EC, and the value for our EC is 3. Okay, so in this case, 3 plus 3. 3 plus 3 is equal to what? 6. 3 plus 3 is equal to 6. Okay, so assuming this is what? Assuming this is our equation 1, and assuming this is our equation 2, what have you realized so far? Can anyone tell me what he or she has realized so far before we move on? It's just a suggestion, okay? Feel free. Non-scoring. What have you realized so far from equation 1 and equation 2? Okay, Roxanne, please, you can share with us.
Okay, so you can substitute equation 2 into equation 1.
No, we are just...
No, equation 1 into equation 3 rather, equation 2 rather.
No, we are not going to substitute equation 1 into equation 2. Like, we're only just going to compare both of them. Okay, so let me help you. Thank you very much for putting an effort. Okay, and the only comparison you can make between or among equation 1 and equation 2 is that you realize that your R is 5. Okay, and this has led to what? A total number of 6. So at the end of the day, the structure is going to become what? Unstable, because your 3 plus EC, which is your constant, is more than the reaction.
Yeah.
Can you see what I'm saying?
Yeah.
So finally, we are going to say that what? Therefore, your R, let me put it this way. Okay. So therefore our R, let me say, therefore R, no, yeah, it's R is what? Less than 3 plus EC. Okay. R is less than 3 plus EC. Small. Practice make man perfect. Just practice it more. You realize that you are going to find it very, very simple. Your mid-sem, you are going to even write. You are going to find, you'll be doing most of these calculations in it. So even in the mid-sem, if you don't know how to solve problem or lecture 1, or you find lecture 1 very challenging, you are going to struggle. Okay. Better still, I'm going to be sending the video to you so you can play it more often to aid your understanding. So at the end of the day, therefore, our reaction is less than the 3 plus EC. So realize that the structure is going to become what? Statically unstable. Statically unstable externally. Please always remember to add externally, okay, to complete the grammar. Okay, so this is statically unstable externally. Please, any questions so far? Please, any questions so far, or we can proceed?
Okay. Sir, please, can you ever solve this question and get a negative answer for the maybe the EC, the degree of static indeterminacy?
0, 1, 2, 4, 4.
Okay, please let's all mute our mics, okay? Before I give him an answer, can anyone help? Can anyone help him? Or can anyone answer his question? Is anyone having any idea of an answer to his question?
I didn't know alone.
Please, you can't get a negative. You can't get a negative answer, okay? In this case, the question is always going to be set in such a way that you are going to get a positive answer. Okay. Okay.
So please, can you get 0?
Can you get 0?
Yes.
No, you are not going to
Ask
get,
them.
No,
you are not
no,
going
I'm not.
you are not going to get 0 because the reason why you are not going to get 0 is that the thing is that the rule is what? R minus what? 3. So we are only going to be calculating for the degree of static indeterminacy if the thing is more than 3. So if the thing is more than 3, do you think we can ever get a negative answer? We can never get a negative answer because I didn't more than 3. Now say you 3 if you want. Something will be left. Okay. So we can never get a negative answer, and we can also never get 0.
Okay.
Okay. Thank you very much
Thank
for
you.
the question. Okay. I
Thank
believe
you
it
for
has
your
also
work. So sweet.
enlightened others. So this is
Yeah.
statically
Yeah.
unstable externally. Okay. So is anyone having any question to ask so far about the problem 1 we just solved? Or we can proceed. Is anyone having any question to ask so far? Hello.
Hi.
Hi.
Are you all okay? Or anyone has a problem or a question he or she wants to ask?
Please, I have a question.
Okay.
We are okay.
Okay, I'm listening. Someone said he has a question.
So when are we supposed to apply the less than and the greater than? It still confuses me.
The less than and the greater than still confuses you.
Yes, please.
Okay. The basic concept I want you to know is that you put it in your head that if I'm equal to 3, then it means that I'm statically determinate. Okay. But if I'm not equal to 3, then it means that me myself, I'm not stable. Do you understand?
Okay.
So it's just like a basic concept. Let's say that we say that we want ATU students to behave in a 3-dimensional way. Okay, and that is our basic concept or standard we have put aside. So if at the end of the day we say that we want people to behave in a 3-dimensional way, that is our standard, and you are behaving a 2-dimensional way, do you think you are stable?
No.
No, you are not.
You are not stable. Okay, someone may see you like, are you all right? And also in a case whereby we say that everyone should behave in a 3-dimensional way and you are behaving in a 4-dimensional way, how should we classify you? You see, then you become indeterminate. If once they add the English into something, it means that the opposite of the thing. Okay? So please don't get confused. It means the opposite of the thing.
Okay.
So this is the table. It means the opposite of the thing. So it's just that the in that has been added to here is making the changes for you that you are seeing. But if I say you are patient, it means you have patience or you have time to handle situation. But if I say you are impatient, it's a different situation altogether. Okay. If I say it is possible, it means it will come on. But if I say it is impossible, it means it won't come on. So you see the way it's behaving. So the determinate is the original thing, and the indeterminate is the opposite. You are going wayward. Do you understand? So please, are you okay, or you still want me to throw more lights on that?
I think I'm okay now.
Okay. Thank you very much. If no one has any other question, let's analyze problem 2 and let's see if we could analyze problem 3 along the way before time finally catch or beat all of us up. Okay. So quickly, without talking much, let's consider the B part of the question. And the B part of the question is also a what? You realize it's also a continuous beam. Okay. But in this case, it is having how many supports? How many supports is it having?
Say 4.
There is
8.
support.
I'll break your waist. The one who said that is having 4 supports, and I'll break your waist. It is having 3 supports, and the first one is a hinge support. The second one is a roller support, And the
So I
third,
was talking about I was talking about the reaction. Sorry.
oh, okay. No problem. That's right. I nearly broke your waist. So
Oh, I beg.
so this is and we say that the ruler from our formula, which is what? R H F is equal to, or let me say, you can also write it the opposite way. 1, 2, 3 is equal to RHF. Okay, so the one is your hot roller. So roller support has what? One reaction. This guy also have one reaction, and this guy, which is the H, has what? Two reactions. At the end of the day, what can we discover? We have discovered that it has equations of conditions over there. As a matter of fact, if I see equations of conditions in questions, I become sad because I realize that it will rather cause you to think more. Okay, once you see equations of condition in the problem, you have to take time and analyze the question. Okay, you don't approach it as questions that don't have ECs in them. Okay, so this time let's take our time. So how many EC do we have in the question? We have two. So this is one. This is also another one. Okay, so at the end of the day, we realize that our total number of reaction is equal to 1, 2. Our total number of reaction is equal to 3. It's 4. Okay, our total number of reaction is equal to 4. So our total number of reaction is equal to 4. And our EC in this case is going to be what?
Say 2.
Thank you. So our EC is equal to 2. This alone, if you're able to do even this alone before going to your answer booklet to solve your question, you realize that whilst others are suffering, you already have the plan already. So you just be moving.
So say it will be statically unstable, right?
Okay, that's what you are saying. Write it somewhere.
Yes.
At the end of the day, if we are done solving the problem, we will discover whether it will be determinate, unstable,
Okay.
or you said that it will be what? Statically what?
Unstable.
You are saying it will be unstable. Okay. What's your
be
name?
determinate.
Yes. Okay, so we shall see. Okay. So let's continue to dive in and see whether what you are saying is true or not. Okay. So at the end of the day, we are either going to prove or disprove your answer. Good.
Okay.
So because we are in B, we are in trial B. So this is trial B. This is trial B. And in our trial B, first of all, we say we draw the problem. Okay. And our problem is normally our given. So you write given on the question paper. Then after writing given, you just draw the problem. Okay. So this is the problem we are having over here. Please, am I moving too fast?
No, say I'm moving too slow.
Thank you.
Yeah, steady why.
So this is a problem. This is a problem I have just drawn over here.
Yeah.
I learned your results will be released soon.
Hey.
In fact, I can't wait for your results to be released. Okay. For now, before you can, or before we feel you are also part of ATO, or you are also part of us, or you are also feeling or going through what we are also going, your results will have to be released for you to also feel the kind of pressure of what we are going through. Okay. So I believe if the result is released, and everyone is going to be very stable on campus. Yes. But don't worry, okay? This is the time you should all be praying. Okay, because you don't know who is going to mark your paper. Okay, so please be prayerful. Okay, so that things will work out well for you. Then this semester, if you work hard, next semester scholarship opportunities are going to be coming out and you'll be cashing out. Okay, so please, and a very big please, this is the time for you to work hard, because after these exams now, scholarship opportunities will be coming out. But you don't have a very good GPA, you realize that you won't be able to get one. Okay. And in that case, cash na yeah geno, scanner yeah geno, won't mean GBO. You so please and a very big please work hard, okay, so that life can be much more easier. Okay, so okay, this is our original structure. This is our original structure. Then after drawing the original structure, you realize that these are the hinges, okay, and this we said that these are the ECs, our equation of conditions. Good. So now we are going to our solution. Okay. So in the solution, this is what we are going to be doing, or this is how we are going to go about the problem. So this is our solution. So in our solution, can someone tell me the first thing we are going to do? Hello, please, can someone tell me the first thing we are going to? Okay, Enoch, please
Yes.
tell me what are we
We'll
going to
draw the
Free
free body.
body diagram.
Okay, thank you very much. So we are going to draw the free body diagram. Okay, we are going to draw the free body diagram. We're going to draw the free body diagram. We're going to draw the free body diagram. Okay.
Okay.
And this roller support, this is the reaction for it. And in the free body diagram, you don't draw the support again. Okay. You just represent the support by the reaction. Okay. And this is our free body diagram. Please take.
Please, I want to ask some questions here.
Okay, I'm listening. Please, I'm listening.
Last week during our class with the master.
Yes.
He says that the drawing.
Yes.
We should make sure like we use the same let's say the way you drew your own. No?
Yes.
The free body diagram. That's what he used. Like the way you draw your drawing.
Okay.
Like we shouldn't use the different method. If it is straight line, we should use straight line. If it is like the way you draw the original one, we should use that one. But like I'm getting confused here.
No, the issue is that I'm saying that see, I don't want you to lose marks at all. In fact, marks are very precious to me. So if I see someone losing marks, I feel pity for the person. Okay. Do you know that if you draw the problem, the original question in your answer booklet before solving the question, do you know that you'll be given a mark? Because it tells the examiner that this is the question you are solving. But if you don't put the problem over here, how can me as the marker know that this is what, meanwhile, maybe even your free body diagram that you drew, you didn't draw it well. So how do I know whether you are doing the right thing or not? Okay. So
Okay.
you have to put the problem down for me so that me as the examiner, I would know that, oh, okay, this is how this is supposed to look like. So that even if you are wrong, I'll be able to examine or correct it. But if you just go straight for it to draw a free body diagram, you could be drawing a wrong thing over there. And how would I know? But if you represent the original
like
problem with the supports, then I'll be able to see that, oh, okay, because it's a roller support, that's why you're writing one reaction. Because it's a hinge support, that's why you're putting two reactions. Oh, okay, because there is also another one roller over here. That's so you see that it makes more sense. Okay. So please, and a very big please. I want you to get, I don't want you to lose marks. Okay. So you put this down for 2 or 1 mark, and come and also put this down for another 2 or 1 mark. Then you realize that you're already on your road to success. Okay. So let's come to our classification. In the classification, how many number of reactions do we have so far?
4.
Okay. So we are just about to find out whether we are about to prove or disprove what or the theory our colleagues have propounded. Okay. So this is our classification. In 10 minutes time, the link is going to go off again. So we all just have to click it for the last time, and then I think that would have been all. Or better still, I could still leave the rest to you as an assignment. Okay, you can do it and send it to me. I'll mark and review for you. These are possible examination questions.
Okay, then say I'm sending my own to you.
Oh, you've tried all of them.
Hey, brother.
Okay.
Calm down.
So this is this is the number of reactions. And the number of reaction is equal to the number of reaction, comma, R is equal to 4. And also equation of condition. Equation of condition. Our equation of condition is how much?
2.
Okay. So our equation of condition, comma, is equal to 2. Please, in a very big place, I want to put a different task ahead of you guys, okay? And if you're able to do this, it's going to enlighten you really well, and it's going to make learning much more easier for you all, okay? Please try and learn how to use the Zoom, okay? So that even if you are home, you can learn from a distance among yourself, okay? You don't necessarily always have to meet on campus before you do group studies. No. If you know how to use the Zoom among yourself, you could just organize online class for yourself among yourself, and one person will take the lead for the class and explain certain things to you all, okay? So please learn how to use the Zoom. If you don't know how to use it, you can still make a time with me. I'll teach you guys how to use it so that it can make, or it can enhance learning among you. Okay, this semester, that is the other task I want us to add as part of our whatever we'll be learning this semester. I don't know if you're able to learn how to use Zoom. You are going to cash out and you are going to thank me later. Okay, so let's come from there. Where do we go to? Because our equation of condition becomes 2. You realize that we have to apply what? The table 2. Okay. And I also told you that anytime you see EC, this EC, equation of conditions in the problem, you know that table 1 is no more applied, but rather table 2. Okay. So from our formula, we said that 3 plus EC. And this is what, this is the constant we are going to be comparing to our R. Okay. The R is a constant on its own, and the 3 plus EC is also a constant formula on its own. So at the end of the day, if you find EC in the question, it means that you have to apply this rule. Okay. Because we have seen EC, that is why we are applying this rule. So we have to add the constant to the EC. And if we add 3 plus 2, what are you going to get? We are going to get 5. We are going to get 5. Okay. So you just realize that we have found an answer to a problem which we have been anticipating. Okay. So the 3 plus 2 is equal to 5. So finally, we can now classify the structure then. Okay. The equation of condition is just a continuation of this. Okay. Let me write them as points so that you see how it is. Let's say this is point 1. This is also a continuation of this. Okay. So this and this I've written over here is just a continuation of that, but I can't continue over there. That's why I've come to the next line. Okay. So in our third aspect, what are we going to be doing? We're going to be doing therefore in this case. And in our therefore, what is our therefore going to become? We say that
R is lesser than 3 plus EC.
So therefore, because R is 4, and the EC becomes 5. So it means that the R is already lesser. Okay. So the R is lesser.
Practically unstable. Good. Externally.
Divine, so what?
Hey, I know share that found.
Me share that even found.
So this is 3 plus EC, and this become what? Statically unstable. Externally. Correct. You have to add externally. For me, there, if I'm marking your paper and
externally,
it's just like if you don't add a unit, I'll mark you wrong. Okay. Because we are engineers. You realize that if a doctor makes a mistake, he or she can kill one person at a time. But for we, the least mistake you make, you are going to be killing like thousands of people. Okay. So you realize that we have to be more competent. Okay. So this is what? Statically unstable. Statically unstable. Okay. So please, and a very big, please try and always try to review your work before submitting. Okay.
Okay, sir. Okay, sir.
Last
Day
sem-
for you, sir.
last semester, I think that was one mistake I made in a particular course. After I was
Oh.
done, I could have gone through over and over again to identify my mistake. I had to submit the paper before later I realized that no, I did a mistake. Okay, and that affected me much. So please, if you are done in the exam hall, wait till the time is up before you go. Okay, go over and go over and go over and go over and go over again, because that is your life. That is what you have been sacrificing for all throughout the semester. Okay, so the exam day, is that only chance you can prove to the examiner that you attended the lectures and you understood whatever he really taught. But if you are not able to prove him that you really understood whatever he taught, then you realize that you are going to face challenges or you have to risk it. Okay. But with time, I believe things are going to be much more better. So he was right. So we realize that this is going to become statically unstable externally. Okay. So please, I want to take some few questions before we solve the last problem. Okay. So please, is anyone having any question? Is anyone having any question to ask so far? I want someone to ask a question before we proceed. Is anyone having a question to ask so far? So can I ask you people a question?
Yes, sir.
Yes, sir.
Okay. Assuming R was 6. Assuming our reaction was 6, what is going to happen? Assuming our number of reaction, which is the R that we are getting for over here, it was 6. What is going to be happening in this case?
I think
So-
it will be
Statically indeterminate.
Indeterminate external.
Externally.
Okay, good. So you have all tried. It will be indeterminate externally rather.
externally.
So if
Yes.
it is indeterminate, then what are you going to be doing?
You find
The-
the degree of indeterminate.
Find for the degree.
You find for the degree of what?
The determinate.
The
Degree of
indeterminate.
external indeterminacy.
Okay, so you are going to find for the degree of the word is static. Okay, you guys are not adding the word. You're not adding the grammar to it. The word is you are going to be finding for the degree of static indeterminacy. Okay, if the structure you realize that it is statically indeterminate, it means you have to calculate for the degree of static indeterminacy. So in doing so, what would have been the answer? Could someone quickly brief us through that? Let me just draw a circle over here. I'll clean it later. So if, let's say, we realize, okay, we are saying blah blah blah, it will be indeterminate. So how do we calculate for the degree of our static indeterminacy? In that case, you are going to use this formula. Okay, that is R is equal to R minus what? 3
plus
3 plus EC. Okay, and in this case, what is going to happen?
So you subtract, you write 6 minus 4. So 5, 6 minus 5.
Please come again.
The R was 6. You said R should be 6, right?
Good.
So
So
6.
So this is going to be 6 minus what?
6 minus 3 plus
3.
And but we already
Yeah,
know that
so 5.
it's 5.
So say
Yeah,
so
so
say
1.
to be
So you realize
1.
that it will be 1. Okay.
Determinate.
Yes.
yes.
So how
Yeah,
do we,
one.
so how do we classify the structure at the end of the day?
So say to be the degree of static indeterminate under the first degree.
Thank you. So the structure is going to be what? Statically indeterminate to the second degree. To the first degree. It's not second.
Yes.
It's rather going to be
To the first degree.